Hello and welcome. Today, we're doing something a little different. We're going to go on a really deep journey, a masterclass, if you will, into the world of Telco Cloud. And we're not just scratching the surface. We're basing this entire deep dive on some incredible exclusive research from the industry analysts at Omdia to really get to the core of what is, without a doubt, one of the biggest transformations the telecommunications industry has ever seen. So let's get right into it. Let's start with the absolute basics, but let's really break this down. What on earth is Telco Cloud? Well, at its very heart, it is a truly fundamental shift in thinking. For decades, literally decades, telecom networks were built using these dedicated, single-purpose hardware appliances. Think of them as big, expensive, specialized boxes. You'd have one box that was your firewall, another box that was your router, another that handled subscriber data. Each one was a custom piece of hardware from a specific vendor designed to do just one thing. It was rigid. It was expensive. Now, Telco Cloud comes along and completely flips that model on its head. It says, forget the specialized boxes. Instead, we're going to take all those network tasks, those network functions, and turn them into flexible pieces of software. And the really revolutionary part? This software doesn't need a special box anymore. It can run on common, standardized cloud infrastructure. We're talking about the same kind of off-the-shelf servers that power Google or Amazon. So this move from hardware-centric to software-centric, well, it's not just an upgrade. It is fundamentally rewiring the very DNA of the entire industry.
All right, so here's the roadmap for our journey today. Think of this as our guide to building a complete picture, layer by layer. First, we're going to start with the why. We'll deconstruct the absolute fundamentals of cloud native to understand what's driving this change. Then we'll get into the how. This is where we look at the messy, real-world data and navigate the realities of this transition. From there, we'll explore the new way, looking at how network operations themselves have to be completely remodeled. After that, we look to the horizon with the goal, the ultimate path towards a fully autonomous network. And finally, we'll bring it all home by summarizing the key insights and final conclusions from all this incredible Omdia analysis.
Okay, let's begin with Act 1, the why. Really, why would an industry that has operated in a certain way for half a century decide to undertake such a massive, expensive, and frankly difficult shift? The answer, in a nutshell, is the promise of becoming cloud native. But that's just a buzzword, right? Well, Omdia's research does a fantastic job of taking that buzzword and breaking it down into three concrete, powerful pillars. These three pillars are the engine driving this entire transformation.
So, this is the central question we have to answer. Why are these network functions, these core jobs of the network, actually becoming cloud native? The answer, as we'll see, isn't just one thing. It lies in a powerful combination of three key benefits, three core promises: flexibility, scalability, and resilience. Let's take a deep, forensic look at each one of these. First up, pillar number one, flexibility. This is a concept that the old telecom world just didn't have. In the old model, your network gear was physically bolted into a rack in a specific building. If you wanted to add capacity somewhere else, it meant a truck roll, engineers, and weeks or months of work. Cloud native changes everything because the functions are now just software. Think about what this means. An operator can now instantiate, or spin up, a network function almost anywhere. We're talking from their huge, centralized core data centers all the way out to the far edge, maybe a small server sitting at the base of a cell tower. Imagine a huge football game happening. The network operator can instantly deploy extra 5G capacity right there at the stadium for the 3 hours of the game and then just as easily tear it down afterwards. That was impossible before. But flexibility is also about choice. Operators now have the freedom to choose where to run these software functions. They can run them on-premise in their own data centers, or they can leverage the massive scale and innovation of public clouds like AWS, Google Cloud, or Azure. They can mix and match, placing workloads exactly where it makes the most sense from a cost, performance, and latency perspective. It's a level of strategic choice that this industry has literally never had before.
Okay, next up, pillar number two, scalability. And it's really important to understand that this isn't just about getting bigger, it's about being incredibly dynamic and responsive. In the old days, scaling meant a planning meeting, a purchase order, waiting for hardware, and manually configuring it. It was a slow, human-driven process. The cloud-native world introduces a completely different paradigm. We move from a manual, imperative model to an automated, declarative one. So what does that mean? Well, imperative is when you give step-by-step commands. Add a server, configure the IP address, install the software. You're telling the system how to do something. The new declarative model is revolutionary. Here, the operator simply declares their desired end state. They say something like, I want this mobile core service to always be able to handle 10,000 users with this level of performance. That's it. You define the what, not the how. The underlying system, using powerful tools we'll talk about next, then takes over and automatically adds or removes capacity in seconds to continuously meet that declared goal. It's a profound shift in operational thinking.
So how does this magic of declarative scalability actually work? Well, the mechanics behind it rely on a set of incredibly powerful modern tools. At the very center of it all is Kubernetes. Think of Kubernetes as the master brain or the conductor of the orchestra. It's an open-source platform that automatically manages all the underlying resources, the servers, the storage, the networking, to make sure that declarative state we just talked about is always maintained. It's the how that makes the what possible. Then you have a process, a philosophy really, called GitOps. This is another game changer. GitOps allows operators to manage the entire configuration of their network, potentially across thousands of different locations, as simple text files, as code stored in a central repository. This means you can make a change, have it peer-reviewed, and then have it roll out automatically and consistently to your entire network with incredible speed and reliability. It brings software development best practices to network operations. The result of all this? True on-demand capacity, which drives incredible efficiency. You only use what you need when you need it.
And that brings us to our third and final pillar, resilience. In the past, if a piece of hardware failed, what happened? Alarms would go off, and some poor engineer would get a wake-up call at 3 a.m. to go and manually fix the problem. In a cloud-native world, the system is designed to be self-healing. This is a huge deal. Let's say a piece of software, a network function, crashes. An orchestrator like Kubernetes, which is constantly monitoring the health of everything, automatically detects that failure within seconds. Without any human intervention, it immediately terminates the faulty instance and spins up a brand new, perfectly healthy replacement. The service recovers automatically, often so quickly that end users never even notice a problem. This automated recovery, this concept of self-healing clusters, dramatically improves the reliability of the network and frees up human engineers to work on more valuable tasks instead of just firefighting.
So, we've covered the why. We've seen the incredible promise of flexibility, scalability, and resilience. It sounds amazing, right? A complete no-brainer. But now we have to transition from the beautiful theory to the messy reality. What does this transition actually look like in the real world for these massive telecom operators? Well, this is where Omdia's survey data is so fascinating because it shows that it's not a clean, overnight switch. It is a complex, measured hybrid reality where the old world and the new world are forced to coexist for a very long time.
Now, take a look at this chart. This data really tells the story of the transition. First, let's just quickly get the acronym straight. PNF stands for Physical Network Function. That's the old-school dedicated hardware box. VNF is a virtual network function. This is where the function runs as software inside a virtual machine, which was kind of the first step away from physical hardware. And CNF is a cloud-native network function. That's the new world, running in lightweight containers managed by Kubernetes. Now, the overall trend here is crystal clear. The blue bars, the physical boxes, are declining. The green bars, the cloud-native containers, are growing steadily. No surprise there. But look at the gray bars. The VNFs, that middle step, are not only the most common platform today, but the projection shows they will still be the most common platform in 5 years. They are holding remarkably steady.
This piece of data right here is probably the most surprising insight in the chart, and it forces us to ask a really critical question. If cloud-native containers, the CNFs, are so clearly the future, why isn't everyone just ripping out their old stuff and moving there directly? Why this persistence of the middle ground VNF technology?
Omdia's analysis points to 3 really powerful reasons for this VNF persistence, and they have less to do with technology and more to do with people and money. First, there's the human factor. An operator's staff, their engineers, have spent the last decade learning how to manage virtual machines. They have the skills, the tools, the certifications, the comfort level. Moving to containers and Kubernetes is a whole new world that requires massive retraining. Second, there's a perception of security. The thick, hardened walls of a virtual machine with its own full operating system are still seen by some in the industry as being more secure and more isolated than a container which shares a kernel with its host. This perception, right or wrong, makes operators cautious about moving certain sensitive functions. And third, and this is a huge one, is investment cycles. Operators have spent billions upon billions of dollars building out their VNF infrastructure. You simply can't afford to throw all of that away overnight. You have to maximize the return on that existing investment.
This complex, hybrid reality leads us to another key trend that Omdia's data highlights, and that's the move toward what's called a horizontal cloud. For years, telcos have had these huge silos. They had one cloud stack for their IT department, running things like billing and customer support, and a completely separate, specialized stack for the network functions. A horizontal cloud aims to break down those silos and create a single, common platform for both IT and network tasks. And what this data shows is that this is not just a theory, it's happening. If you add it up, over 80% of operators have already started this journey in some way, whether it's by combining their underlying infrastructure as a service, their container as a service platform, or at the very least their management and automation tools. The direction is clear: break down the silos.
But let's zoom in on that other number, that 19%. Almost 1 in 5 operators still run completely separate siloed cloud stacks for IT and the network. So why would they do that when the trend is clearly towards horizontalization? Well, a really big part of the answer comes from the network vendors themselves. The companies that sell the network function software often argue that their specific application needs a special, dedicated, fine-tuned stack to guarantee performance and reliability. Now, while there can be some truth to that, it also has a very convenient side effect for them. It creates vendor lock-in, making it much harder for the operator to switch to a competitor. This vendor pressure is a major force working against the industry's goal of a truly unified horizontal cloud.
So, we've seen that the technology is shifting toward this hybrid cloud-native world. It's only logical that this technological shift demands a massive operational one to go with it. You can't manage a new type of network with old-world thinking. This brings us to our next major section, the new way of operations. And what we find here is a fascinating tension, a clash of two competing philosophies, one born from the traditional telecom world and one born from the modern cloud world. On one side of this philosophical divide, you have something called ETSI NFV. ETSI is the European Telecommunications Standards Institute. This is a highly structured, top-down framework designed by and for the telecom industry. It has detailed specifications for every little piece of the puzzle. It's all about standardization and interoperability, which are traditional telco values. On the other side, you have GitOps. GitOps isn't a standard. It's a set of practices and principles that emerged organically from the fast-moving, agile cloud world of companies like Google and Netflix. It's a bottom-up approach focused on automation, declarative configuration, and treating your infrastructure just like you treat your software code. So you have this tension. One is top-down and standards-driven, the other is bottom-up and practice-driven.
And this Omdia data shows exactly how that tension is playing out in the real world. If you look at the chart on the left, you can see that today the telco-centric ETSI framework is still very important. A majority of operators say it's an important consideration in their architecture. But then look at the chart on the right, which looks to the future. When asked if they believe that cloud-centric GitOps frameworks will replace ETSI NFV by 2030, about half of the operators agree. The writing is on the wall. The mindset is clearly shifting. Operators want to manage their networks with the speed and agility of modern software companies.
But it's really important not to view this as some kind of epic battle to the death where one side has to win and the other has to lose. The reality is much more nuanced. As Omdia's analyst James Crawshaw points out in this quote, the future is much more about evolution and collaboration. ETSI isn't standing still. The organization is actively working to adopt and incorporate these cloud-native ideas into its standards. And the key, as he says, is collaboration between the traditional standards bodies like ETSI and the open-source communities like the Cloud Native Computing Foundation, which is part of the Linux Foundation. The likely end result isn't a wholesale replacement, but a hybrid approach that takes the best ideas from both worlds. This brings us to our final major section of this deep dive, the goal, the ultimate endgame. Why are we doing all of this? Why are we going through all this pain of transition, remodeling operations, and learning new skills? The answer is the pursuit of a fully autonomous network, a network that can largely manage itself, heal itself, and optimize itself with minimal or even zero human touch. Now let's connect all the dots and see how every single piece we've discussed so far, flexibility, scalability, resilience, GitOps, are the essential, non-negotiable building blocks for this zero-touch future. This slide is so important because it lays out the entire path, step by step. Let's walk through it. First, moving to microservices and using CI/CD pipelines for continuous integration and deployment. That's what enables true agility. You can update small pieces of your network independently and automatically. Second, as we've discussed, containerization and orchestration with tools like Kubernetes is what provides that foundational resilience and self-healing capability. The network can fix itself. Third, Kubernetes also enables self-optimized resource allocation. It's smart enough to pack workloads onto servers efficiently, automatically, without a human needing to manage it. Fourth, modern APIs and that declarative configuration model we talked about, that's the key enabler for what's called intent-based networking.
This is where an operator can state their business intent. For example, guarantee ultra-low latency for this connected ambulance, and the network itself figures out how to make it happen. And finally, all of these modern software-based systems make it incredibly easy to extract vast amounts of data, or telemetry. And that data is the fuel for the artificial intelligence and machine learning engines that will ultimately drive a truly autonomous network. Each step builds on the last.
Now, that vision of an autonomous network is incredibly powerful. It's the promised land. But this chart from Omdia provides a very sobering reality check. When they asked operators, what are your biggest challenges to actually achieving network automation, technology itself wasn't the top answer. Look at the two bars that are head and shoulders above the rest. The number one challenge is interoperability with existing networks, and number two is the employee skill set. This is so critical. The hardest problems on the path to autonomy aren't just technical, they're about dealing with legacy systems, and most importantly, they're about people.
Let's dive a little deeper into that number one challenge, interoperability. The core of the problem is that these shiny new automated systems can't live in a vacuum. They have to talk to all the old stuff that's still running the network. You might have a brand new, fully automated 5G core that has beautiful modern APIs. But for it to work, it probably needs to get information from a 20-year-old billing system that was never designed to be automated and has no modern APIs at all. Building the custom bridges to connect the new world to the old world is incredibly difficult, expensive, and it massively slows down the pace of automation. And even when industry standards do exist, vendors often interpret them slightly differently, leading to subtle incompatibilities that require even more custom integration work to fix. It's a huge headache.
And now for that second major challenge, which is arguably even harder to solve, the employee skills gap. For decades, being a great network engineer meant having deep expertise in configuring routers and switches using a command line interface. That knowledge is still valuable, but it does not directly translate to managing a modern cloud-native network. Today, you need a completely different set of skills. You need to understand infrastructure as code, using tools like Ansible or Terraform. You need to be able to package and manage complex applications on Kubernetes, using things like Helm charts. You need to know how to write scripts and work in a DevOps culture. It's a massive cultural and educational shift, moving from a network engineer to more of a network software developer. And this requires a huge investment from operators in reskilling their workforce.
Wow, we have covered a tremendous amount of ground. We've gone from the fundamental why all the way to the ultimate goal of autonomy and the challenges that lie in the way. So, to wrap up this deep dive, let's take a moment to step back and crystallize the absolute key insights and conclusions from Omdia's fantastic research. So, what are the most important takeaways from our journey today? First, at the end of the day, this entire cloud-native adoption is being driven by the pursuit of those three core pillars: flexibility, scalability, and resilience. That's the business case. Second, remember the data. This is not a flash cutover. We are living in a hybrid world, where new cloud-native functions will have to coexist with older virtual network functions and even some physical network functions for the foreseeable future. Third, operations are in the middle of a massive philosophical shift, evolving away from rigid telco-specific frameworks like ETSI and FE and towards more agile cloud-native models like GitOps. Fourth, the walls are coming down. The industry is clearly moving towards a horizontal cloud, breaking down the old silos between IT and the network. And finally, and perhaps most importantly, realizing the ultimate goal of full automation depends less on new technology and more on solving the very human and legacy challenges of interoperability and closing the employee skills gap.
And so after this entire deep dive, we end with this one final provocative thought to leave you with. The technology path towards a more automated, intelligent network is becoming clear every single day. The tools are there, but the real question is this: are the operators, the organizations themselves, truly prepared for the monumental human and cultural transformation that is required to achieve true network autonomy? Because as all of Omdia's research highlights, that question, the human one, will ultimately determine the pace, the pain, and the success of this entire industry-wide shift.